Assalamu alaikum, my dear students. How are you? Hope you will be in the best of health, wealth, and happiness. I welcome you all into my today lecture. Our today lecture is about the transistor, which is one of the most important invention in the history of all inventions. It is the transistor which made our lives so much comfortable. We will discuss transistor in our class today. In the last lecture, I told you about the diode, and diode is an amplifier. And if you remember, in the beginning, I told you that though p-n junction diode wasn't the direct part of our syllabus, but it was considered to be extremely important to study to study rectifiers. And sorry, I talked to you about rectifiers, not amplifiers. So diodes are extremely important in the study of rectifiers, which convert alternating voltages into DC voltages, and amplifiers, which is used to convert low signals into high signals. So the diode is a full wave rectifier, and diode is the half wave rectifier. We have studied it there. Now, let us start with our today topic, the transistor. Now, what is transistor? In fact, the transistor, as I told, that the most important invention of the 50s, and if my memory is helping me, most probably it was invented in 1948 by two American physicists, and they were friends also, Bredon and Shockley. They invented the transistor. The main part here is the transistor. We can use this transistor beside other applications of the transistor. Transistor can be used as a switch, right? And this is how we will explain here. Now let us see that what is a transistor. We can define transistor in many ways. Transistor is a tiny three-terminal device. Three-terminal device. It has what? It has three terminals. The three terminals of the transistor are the collector, base, and the emitter. Better I would write the emitter first, right? And that is the three terminal of the transistor. And in a practical term, I would like to tell you that for the transistor, we have the input terminal, we have a common terminal, a common terminal, and we have the output terminal also, the output terminal. So we have three terminals for the transistor: the collector, the base, and the emitter. Collector, base are the input terminal, and the common terminal and the output terminal. So I will explain these to you. So a tiny three terminal device, that is called what? That is called the transistor. Transistor formation, how transistor is formed. The transistor, sometime I usually tell the class, the transistor is formed when diodes are connected back to back, are connected back to back. So in a simple way, I can say the transistor is the logical extension of diodes. The logical extension of the diode and is one of the extremely important invention, and with its small size and its huge function, it is the most demanding in the world of the electronics. And this is how today you see the very reduced size of the electronic gadgets. It is all because of this. And there is one drawback of the transistor, and which I would like to tell you right in the beginning, that beside all of its wonders, transistor is a heat sensitive device. A heat sensitive device. This is one of the drawback, that it is a heat sensitive device, that the little increase in the temperature may burn the entire device within fraction of seconds. So this is why that care must be taken to keep it cool during its working. So that is it. As I told, it is the logical extension of the it is the logical extension of the diode. Okay, as I told, when two diodes are connected back to back. So here you see, look, diode, for example, this is diode D1, here's diode D2, and as you see here, the two diodes are connected back to back. So for example, if I straighten it like this, and here you see it like this. Okay, so look, they seems to be connected as back to back. Here you also see it, that's connected a back to back. So we have two kinds of the transistors. One we call the mm, the NPN type of transistor, the NPN type of transistor. The other we call the PNP type of transistor. For the NPN type of transistor, as you see here, this is the when the diodes are connected in a way as you see here, and here you also see the electronic symbols and the geometric configuration of how the diode has been designed and constructed here. So in the NPN transistor, you see that when p-type material, look here, when the p-type material is sandwiched between two n-type material, then the transistor form is NPN type of transistor. Right? Here in the diagram, the accurate diagram is not shown, right? And I would like to help you that here these three parts, the emitter and the collector part. Usually the collector part is larger in size than the base part and the emitter. So you see here it has a larger size, and here this is a very small size, and here you see the emitter part is then intermediate, okay, greater in size than the base. I'll be explaining these to you right now. So the PNP type transistor is formed that when two that when the n-type material is sandwiched between two p-type material, right? So this is how the NPNP type of transistor is formed. And here you see the electronic, this is the electronic symbol or the circuit symbol, you may say, for the NPN type of transistor, and here it is for the PNP type of transistor. Now let us go deeper inside. Let's see here, as I told, that we have the three main types of the transistor. Here you see that one, that is, as I told, the emitter part. The emitter part, its job is to inject electrons, into the base, to inject electron into what? it is used to inject electron into the base. This is the job of the emitter. This is the relatively highly doping, relative, relatively high doping here. It is doped high, and then what? Then collector, and but what? Smaller in size and smaller in size. It is small in size. The portion you see here, it's smaller in size. Okay. Now the base part, the common part. The base serve is a common terminal, right? And it is very thin in size, very thin, very thin in size. Here in my diagram, I just exaggerated the base, the emitter and the collector. So it is very thin in size, and very lightly doped, there is the doping ratio very high. Here it is lightly doped, and as I told, that the doping here that is later on I will be explaining the doping also. The base, which I told, that very thin in size in the micron, and very lightly doped, so much lightly doped that practically practically no current pass through it. No current pass through it. I means no, here I means very less for the word no. And then there is the third part of the transistor is collector part. The collector part is that is larger in size, and because here is a hole so much, so that it is larger in size. Okay, but the doping here is, but doping is smaller than the collector part. Sorry, than the emitter part. Here they, what they actually do here, that here they here the collector collects electron from the emitter through base. So these are the three important parts of the transistor. Beside this, the major types of the transistor are the bipolar transistor, it is classified, all the transistors are classified into bipolar transistor and unipolar transistor the bipolar transistor and the unipolar transistor. In the bipolar transistor, the current or the function in the bipolar transistor, the function is based both on the minority carrier, majority carrier like electrons, and the minority carrier like holes. And for the unipolar transistor, there is only majority charge carrier. The function is based on the majority charge carrier. But we would not discuss the unipolar transistors here. Okay, this is not the part of our syllabus here. Whatever the transistor, whether if it is NPN or PNP, that are usually the bipolar transistor. So we'll discuss here the bipolar transistor, but I would like to explain to you the working principle of the bipolar transistors also. The working principle of the transistor is, you must remember that a small change in the base current, a small change in the base current can cause a very large change, a very large change in the collector current, in the collector current. This is the working principle of all the transistors, right? And that is, and I'll be coming to this point later on when I will discuss the configuration of the transistors. So here you see, look, as far as this transistor is concerned, as I told, that look, we have the, see here, in the case of, or this transistor, for example, as you see, as I told, that we have what? Look, I will just make it like this. Here you see we have the base, we have the emitter part, and we have the collector part. As I told, that the job of the base is that it injects electron into the collector. All right, so here the current that is because of the emitter is, this is emitter, it will be denoted by IE, and the sense, as you see it goes, here we have two paths for the current like this one. So the current that's through the collector will be IC, and through the base will be IB. So we have an important equation, the transistor equation, in which IE equals IB equals IC. So as I told, the working principle, changing a small change in the base current can cause a very large change in the collector current, and then I'll be telling this thing to you. As I told earlier, that see here, that since the base is very thin and lightly doped, so as the emitter current flows through the base, only 5% of the current flows through the base, right? The holes recombines, the electrons recombines with the hole in the base region. Since base is very thin and very lightly doped, so only that 5% of the current is, goes to the base, and the remaining 95% you would like to see through the collector. So there, this is why I told in the beginning that a very small current, a small change in the base current can cause a large change in the collector current. I will be coming to that point also. But here, because of its very small size and very thin or lightly doping, I told that I told you that I told you that they the only very limited current flows through the only limited current flows through the base. Okay, so here you would see it like this. Now let us see that what we want to see here is the real or the practical understanding of the transistor. You see here, look, here you see the voltages. This is called the base emitter potential. This one you see is called the collector base potential. These are known as the power supplies, right? They are what? These two can, they power your transistor. So these are just the power supplies. These are what? These are the power supplies. We cannot call them input, or we cannot call them output, right? It has nothing to do with our input and our output. And for the input and output, I would like to tell you that, look, for example, here we have this, and here we have this. Like, let me do it with this red. These two terminal like this one, and here this terminal, and here this terminal. So here the inputs are being supplied to these terminal, the inputs, and here we have the output. Most of the time the student confuses this with the input and output potentials. No, these are called the power supplies. They are not the input or the output. Now, how, for example, the transistor can be used to amplify or to convert low signals into high signals. So how I can put my input signal? For example, look, if here is a microphone, so in the microphone the sound signals are very small, right? So when you feed it in this way and when you use transistor as an amplifier, so the sound signals from the microphone in the form of that electric pulses is your input, and here it is connected these two terminal with a loudspeaker where you hear your sound louder and louder. So your signals are amplified to the very high strength, right? And that is this what the output terminal. In between is the transistor, right? And the other part of the electronic circuit. So you see that output and inputs are different than the supply voltage. These are called the biasing potential differences, right? For the proper working condition of the transistor, later on I'll be explaining this, the proper working condition of the transistor, proper working conditions of the transistor. In the proper working conditions of the transistor, the emitter base junction must be forward biased. It must be what? Forward biased. And the collector base junction must be reverse biased. Okay, these are the proper working conditions. So here definitely you would see, look, this is inside and it is connected with the negative terminal of the battery. So you see that is what it is in the forward bias condition, right? And similarly, if you see the emitter base junction, this junction is called what? This junction is called the emitter base junction, and this junction is called the collector base junction. In the collector base junction, you see N is connected with the negative terminal, the positive terminal of the battery, and P side with the negative terminal. Definitely it is in the reverse bias condition, and the same goes here. So these are the proper biasing conditions for the transistor. Now, for the working of the transistor, as I told, the working of the transistor, working of the transistor. For the working of the transistor, as I told, that there are four possible ways of biasing the junction, four possible ways for biasing junction, and three I would like to explain to you. The fourth is not of our interest. The one we call the active mode or the linear mode operation, the active mode operation, right? I will explain this to you. The second one is the saturation mode operation, where the transistors goes into action, and in the saturation mode operation, here in the saturation mode, there is maximum IC, maximum collector current, right, flows through the transistor, right? That is we can say that it acts like a closed switch, acts like a closed switch in the saturation mode, right? That is, and the current flows from collector to emitter, right? From what? From collector to emitter, right? It is this one. In the That is the saturation. The third one is the cut off mode. Cut off the cutoff mode. Here the transistor acts like an open switch. It acts like what? It acts like an open switch, and that is the no current flows here. In this case, it is in the off state. And then there is the inversion mode also. That is the emitter to collector situation where the terminals are interchanged, but that is beyond the scope of our syllabus, and I don't want to discuss that either. Now, the types of configuration based on these things, the types of configuration. We have two broad types of the configuration. The first configuration is here. Let me explain it to you. First, we have the CB configuration, collector to base configuration. CB means collector to base. Collector to base. It depends that which terminal is common, right? In the collector base configuration, base is common to both the collector and emitter. And when we have the collector emitter configuration, the CE, collector to emitter configuration, right? And then I would revisit all these hairs, right? For the then they have what? Then they have the kind of characteristic here for the collector and the base configuration. The collector base configuration, here we will again discuss two things here. One, the input characteristic CHR, and the other we have the output CHR. Here I will explain this and I will leave it upon you, okay, because it is easy once you understand this. You see here for the input characteristic, the emitter current IE, varies with respect to the base emitter potential at constant collector base potential. This is the input characteristic, while the output characteristic, the IC means collector current. The IC current, IC varies, the IC varies with respect to the IC varies with respect to the base potential, the base emitter potential at constant emitter current, right? IE current. That is the characteristic of what? That is the characteristic, the output characteristic. And the further mathematical uh, situation here would be like the that is the alpha factor. I would like to explain to you, okay, are the amplification factors. Alpha factors are amplification factor that how transistor amplify. This is what I'll be explaining to you here, but first of all I just want to take you back into the diagram here. As I already discussed this to you, that this is called the transistor equation. I already wrote it here, the transistor equation as you see here, this one, but the difference is there because IC will be equal to IE minus IB, and as I told, small change in the IB is causing a very large change in the collector current, and this is how we will learn this from the beta factor, right? From the beta factor or the transistor gain. The transistor gain, let me tell this here because later on maybe I will forget. This beta factor will be equal to the ratio of the collector current to the ratio of the base current. So the collector current is equal to beta into that is beta into IB. Now you know This is always, it depends on the external parameters of the transistor, like its resistance of the transistor and the resistance here. Okay, so that depends on the external parameter, and it is of the order of 10 raised to the power 2. Since it is very high, so if you make a slight change in B, right, a very slight change in the IB current, a small change in the IB can then cause a large change in the IC. Why? Because the amplification factor is very large. As I told, it is of the order of 10 raised to the power 2. So a slight change in IB can cause a very large change in the IC. Now, as I told, the operating mode of the transistor, and I told that we have the active mode operating situation here for, and we the in the active mode condition, I told that we have what, the emitter base junction must be forward biased, the collector base junction must be reverse biased. In the saturation mode, both must be forward biased, and it will act as a closed switch. Right, in the cutoff mode, the transistor does not conduct, and both the biasing modes are reverse. And in the inverse, as I told, they not the part of our syllabus, but just for your knowledge, I wrote it here. That one will be in the reverse and one will in the forward. So you just see that it's get interchanged. Okay. Now, if you see the configuration, as I told, the collector base configuration, and as I told, the collector emitter configuration, and here you see the input characteristic, that is the change in the VAB, and then you see the change in the emitter current, as I told here, that these two can be plotted against. And here the output, I also explained that output will be between the IC and the VCE, and here you see for the various changes in V, you can just see how your IC changes. And the same goes for the collector emitter configuration also. Here you see for the collector emitter configuration also. Now, look, as I told that I'll be explaining to you the amplification factor here. So the amplification factor are the gain, the amplification factor is actually denoted by alpha amplification factor. And this alpha, it is the ratio of the collector current IC to the emitter current IE, right? And usually this alpha is equal to 1. And why? What is the reason it is nearly equal to 1? Since you know that IE is equal to what? IB plus IC. But you know that as IB is very, very small, okay, then the resistance, it is very, very small. So because of this factor, we tends that the IB is nearly equal to 0. And so it is nearly equal to 0. So the IE will be almost equal IC. So IC by IC equals 1. 1. So this may be the part of your exam also, to show that alpha for the collector base configuration, alpha is equal to, yeah, the transistor gain is equal to 1. Here for the collector emitter configuration, as I told, they are explained earlier, that is AC, but here we have what? Here we have the beta factor for the transistor, yeah, the transistor gain beta factor. And what is that beta factor? The beta factor, as I told, that beta is the ratio of the collector current IC to the base current IB. And then if you remember, I earlier wrote that collector current is equal to beta into IB. And then I told, since making small change in IB can cause a large change in IC, it is because of my this mathematical statement I wrote. This is the working principle. So you know, as I told, beta is of the order of 10 raised to power what? 10 raised to power 2. So slightly change IB, you will get large change in the IC, right? Moreover, if you want to express beta in terms of alpha, so that is also not difficult, and beta can also be expressed in terms of alpha, and it will be equal to 1 minus alpha. Beta will be equal to what? 1 minus alpha. Why? Because if you just see, look, you relate these two relationships, find the ice, that is the express the IC in term of what, the ICI in term of alpha. So that is very easy, and I leave it for you. This is your home assignment to prove that beta is equal to alpha into 1 minus alpha, the ratio of alpha to 1 minus alpha. This is as easy as eating ice cream. Okay, so you can do this by using this equation, this one, and this one. You can get here. Okay, so this is all for the transistor. So the applications of the transistors, a lot applications. This is what I would like to add. Application of the transistor is, I told, transistor can be used as a switch. What does this means? To operate a very large current by using a small current, right? And so that is one of the most important application, right? It can be used to generate signals, to generate signals. Third, it can be used to convert low signals into high signals like in the amplifier. So this is how the end of the this is the end of our today lecture. So inshallah, see you in the next lecture. So in my today lecture, you have learned about the transistor, the what does it do, how is it formed, its kinds, types, various configuration, right? Where is the input, where is the output, the biasing supplies, right? These and the transistor gains, you have learned all these in our today lecture. So inshallah, see you in the next lecture. This is the end of the unit 17. So inshallah, in the next lecture we will start unit 18, and that will be I think the atomic spectra. So see you there. Allah Hafiz. Thank you very much.